Here we have example 3 from 9.3 in Math 20-1. And it's a word problem, everybody's favorite, I'm sure. It talks about how Rene, a journalist, has a parabolic microphone that he's pointing at something, whatever it is, and he's picking up the sound. And it wants us to describe the region that Rene can cover with his microphone. And, just logically, if you have a parabolic microphone and you point it north, you're not going to hear anything to the south of where you are. So understanding that parabolic microphone is only going to pick up a specific region is pretty important, because it means you have to aim it. You can't just point it up into the air and expect to hear everything. The best way of doing this question is to start to model it graphically. And the way that we're going to do that is what I would argue is the easiest way possible, which is to put the lowest point, the vertex of this parabolic dish, at the origin. So I'm going to draw a parabola here and try to make it roughly symmetrical about the origin. And then basically what we're going to do is try to identify some points on it. And I just want to identify that the width of this is 50 centimeters and the depth, or the height, they really mean the same thing in this context, is 15 centimeters. Now, because the width is 50 centimeters, and I'm going to move these in a second, I am saying that this dimension would be 50. Now, logically, what that means is that this point up here at the top of the dish is 25 centimeters to the right of the center, and this point at the kind of the left end is 25 centimeters to the left. Now, that left is represented as a negative mathematically. All right, the other concept that was given to us, and I'll try to draw that in the right position, whoops, they tell us that the depth is 15 centimeters, which means that the y coordinate on both of these points is positive 15. Now, there's one other point on the parabola. We very purposely put the center at the origin. Now, the reason that I bring this up, and I'm just going to move these out of the way now, oops, I moved an extra one there, is if I were to give you those 3 points, it is very much expected that you've maintained the ability to solve something like this from chapter 3. So when we talk about, pointing this parabola at something, we would pick up anything in the shaded region, except that shaded region would keep going up. Now, one of the first immediate problems is that we are not going to see anything outside of this positive 25 or outside of this negative 25. And the way that we represent that is that we say the kind of the horizontal distance must be less than or equal to 25 and greater than or equal to negative 25. That's going to give me kind of that tight window that I have to point the microphone at. And then basically what we're going to determine is, how do I describe that region above the parabola? And really what's happening in this question is there's 2 inequalities. There's this guy, the idea that x has to be in between negative 25 and positive 25, but then there's also that quadratic. Now, before we do anything, I'm going to write it like this. Because we're shading above the line, I know that y has to be greater than or equal to, and I'm going to cop out a little bit here, I'm going to put in f of x, because I don't know what f of x is yet. But I'm going to write below it that f of x is the parabola with the vertex at the origin, so that's 0, 0, and then I'm going to identify there's 2 points. There's the point 25, 15, and there's the point negative 25, 15. Now, truthfully, you don't need both those points. You only need one of them, but you do need one of them, because knowing the vertex is at 0, 0 allows me to identify that my p parameter is 0 and my q parameter is 0. So if we talk about that function, that quadratic function, I know now that f of x, and I'll put the general form here, it's a times x minus p squared plus q. We know that that function is some a value. We don't know it yet, but we do know that it is only going to be x minus 0 squared plus 0. That's pretty overkill to write it that way, though. So I would write that f of x is a times x squared. But we need to know what a is. And the idea behind a is it's really what is the curvature of the dish. That's what a ultimately determines. So in order to find that, we need to find a point that's on the curve. Now, 0, 0 is on the curve. There's no denying that. But if you put 0, 0 in there, it is going to work for any a possible. You can make a negative 500 and it would still work. Probably wouldn't open the right way, but it would still work. So what we're going to do, if possible, I like to stay positive. I am going to input x is equal to 25. And I'm going to write here y is equal to 15. It's very important to remember that y is the value of the function x. Now, I would like to summarize this one more time, and function notation is something that a lot of students don't like, but it's very, very important. What this point actually tells me is my function evaluated at an x of 25 gives me a y value of 15. And the reason why I like writing that is I'm going to use it to solve it. F at 25 is a times 25 squared, and 15 is a number, so I'm just going to leave it as 15. Well, 25 squared is rather large. I get 625 times A is equal to 15. So A is equal to 15 divided by 625. Both of those are divisible by divisible by 5. And what I get when I reduce that into lowest forms is that A is equal to 3 over 125. Now that means, and I'll write it here, that my function is 3 over 125 times x squared. But looking all the way back up, and I don't want to move too much, we identified that y was greater than or equal to the function. So the solution to this problem is that y must be greater than or equal to 3 over 125 times x squared, and x has to be less than or equal to 25, but greater than or equal to negative 25. And I do want to write this out now, or draw this out, I should say, that if I was to just draw the parabola, I'm going to do that in green, what I would get, and this is the problem, the parabola keeps going. There's no reason that that parabola would stop. Oh, that's a little bit out of sync. I'm going to try that again. There's no reason that parabola would stop at positive 25 and negative 25. And this is part of the problem with word problems. The parabola itself is everything above this region, and I'm going to shade that in green. Or everything above this region, everything above this line. The other inequality, though, is that x has to be greater than negative 25 and less than positive 25. So I'm just arbitrarily going to put negative 25 here, and positive 25, try to make it roughly symmetrical, is right here. That region, and I'll draw these solid lines, is drawn in red. Now, this is an important thing that you have learned in the past, but it's been a while since you talked about it. Because both of these things need to be true, the solution is where these regions overlap, which is going to be everywhere that I'm kind of coloring in this dark blue section. And that it does make this trickier, that all two of those inequalities need to be true, but the basic idea is that anywhere those inequalities overlap becomes the solution to the problem. And, you know, if we think about this conceptually, I want to grab a point here. Let's grab the point 24, 0. If I looked to test 24, 0, what would happen is that it is in the red region. So if I put 24 in for x, 24 is definitely less than or equal to 25, and it's also greater than or equal to negative 25. So it is confirmed there. But when I plug it into the other problem, I get that other inequality, 0 is greater than or equal to 3 over 125 times 24 squared. Now, I'm not even going to put that into my calculator because there's no possible way that this right-hand side would be less than 0. It's going to be a positive number. Every positive number is, greater than 0. And so this would not be solved. And you can see that on the graph, that this red dot that I put is in the red shading, but it's not in the green shading that kind of got lost. This green shading right here is only above the parabola. And it is a bit of a hard concept. Once we start to work with, real world examples, it is very, very beneficial to draw this out. And more importantly, think about if there's any restrictions on the variables based on what they're representing. And we'll see that in the next example.